Hello students, good morning to all of you. Today we are going to discuss about another important concept in current electricity. This is the second part. Right, in the first part I have given so much of information, yes or no, about current. So what is the current, what is the ampere, what is the SI unit, what is the drift velocity, what is the mobility, what is the relaxation time, what is the relation between drift velocity and current and what is the relation between drift velocity and current density. Okay, and what is the conductivity derivation. Okay, so this and all I have given. So now in this session I will give you very important concept as again. Okay, most important concept is Ohm's law in this session, as well as resistance, conductance and conductivity. This and all will be there, right? Okay, so now first concept I have given, constitution of current in different gases. Not only gases, in the solids, liquid and gases. Mean, what are the current carriers? What are the current carriers are in liquid and gases and solids? Okay, what are the current carriers? So what are the current carriers? So current constitution in solid conductor. That means, so what is the constituents? What are the constituents in solid conductor? Solid conductor. Who are current carriers are in solids. That is the meaning. Who are current carriers in solids? Who are current carriers are in liquid? Who are current carriers are in gases? Like that we are a small concept only. Alright, so generally we know what is that. So in conductor is having free electrons. Conductors are having free electrons in, right? Yes or no? In the outermost cell which is having free electrons. For example, here I have one of a conductor. So this is the one of your conductor. This is the atom. Free vessels I have given. So this is a nucleus. So here outermost shell which is having free electrons. These free electrons can move from, so whatever, negative terminal to positive terminal, right? Negative to positive terminal. It is a moves from here to here. Freely it can move. You know, current means the flow of charge. Current means the flow of charge. That means these free electrons are constitutes current in conductors. Okay, that's what here current carriers. Current is produced by these free electrons. Current constitutes by these free electrons. Correct? That is the solids. So simple question only. What are the current carriers are in solids? Simple question. What are the current carriers are in solids? So free electrons. That's it. Free electrons. Similarly, what are the current carriers are in liquid? What are the current carriers are in liquid? For example, here I have one of a liquid. So for example, NaCl. NaCl. Alright. So like that we are having, you know, NaCl. Na atomic number is 11. Cl is equal to 17, right? Configuration 1s2, 2s2, 2p6, 3s1. This one is 1s2, 2s2, 2p6, 3s1, 3p7, 3s2, right? Sorry, 3s2. So 10, 17. 5, right? Extremely sorry, 5. Yes or no? That means, so which is having outermost shell is one free electron. Here which is having 5 electrons. That means, so a stable configuration purpose here required 1 electron. So here stable configuration purpose it can lose, it can want to lose 1 electron. Yes or no? Sodium can lose 1 electron. Mean what would be happen? It can get so what is that? So stable equilibrium, stable electron configuration, stable electron configuration. Yes or no? So that's what here. Sodium can lose 1 electron. Chlorine can get 1 electron. That is why here Na plus Cl minus can form. Correct? So for example here, so what is that? So here we are having one of a beaker. Here NaCl I have given. So this is the electron configuration. Electron configuration like that will be there. Yes or no? Outermost cell, one electron will be there here. 1, 2, 3, and 4, 5. Yes or no? Like that will be there. That means this electron, these electrons, extra electron will be there. So 2, so 6 will be there here. Okay, 6. And here 2 will be there. Total 8 will be there. Yes or no? So 1s2, 2s2, 2p6. Correct? Here one more also will be there. You know electron configuration, all those things. Alright. So electron configuration. So outer shell. So this is the 2. This is the 2s2, 2p6, 2p6, 3s1. One extra electron will be there. These electron can move from here to here. That is why here Na plus can form. So this is the, how many cells are there? How many electrons are there? Here 2, here 2, 6, and here 1, 2. Yes or no? 3, 4. Right? So how many cells are? How many will be there here? So one extra is will be one extra. Correct? That means here one is required. So here 6, here 6, here total 8 is required. So that here, so 1, 2, 3, 4, 5, 6, 7 will be there. So 8 is required. 8 is required. That is why here one electron came from here to here. In that case, what happened? This is the Cl minus. That means flow of electrons. Flow of electrons. So this is will get positive charge. This is will get negative charge. Correct? For example, here if I give, so what is the electricity? Correct? This is the negative. If I give mean here positive. If I give here negative. If I give mean what happened? Electrons can move. A chlorine molecule can move from here to here. Chlorine ion, sodium ion can move from here to here. The flow of electron. The flow of electrons. Correct? The flow of electrons. That means here in the, so liquid electrolytes, we can call it here electrolytes. Current in liquid electrolytes. Current in electrolyte means gases, liquids. Electrolyte means liquids. In the liquids, what are the current carriers? Current carriers are ions. Positive ions and negative ions. Correct? In solids, free electrons. Similarly, in the liquid, ions are the current carriers. Positive ion as well as negative ion. Positive ion as well as negative ion is the current carriers. That is why here in electrolytes, the current is due to positively and negatively charged ions. In the solids, free electrons. In the solids, free electrons. Okay. Similarly, in gases, you know, gas is the generally bad conductor of electricity. Bad conductor of electricity. Yes or no? Yes, it is a bad conductor of electricity. But I want to, okay, I want to good conduct. That means conduct. It can conduct the electricity. How it is possible? So only one process will be there. That is the by ionization. By ionization. Ionization means we want to extract electron from in that atom. Okay, one atom we have to extract. In that case, what happened? That the atom is get to positive charge. Positive ion. Next, this electron is the free electrons. Correct? By doing ionization. In that time only gases can conduct electricity. Otherwise, do not conduct electricity. Okay. How it is possible, sir, ionization? Yes, which is two process will be there. Generally, two process will be there. What is the first process? To give the high potential. To give the high potential voltage. High potential. What is that? To apply the high potential difference at low pressure. At low pressure, you have to apply the high potential difference. In that case, the gas will become ionized gas. The gas becomes ionized. That means it can ionization is possible. That gas is ionized. That is the one process. Second one is by their exposure of X-rays. X-rays, if I apply X-rays, in that case what happens? The gas becomes ionized. That ionized gas is having positive ions and electrons. Remember, positive ions and electrons. So now positive ions, electrons can move. The flow of positive ions and electrons can constitute electricity in the gases. Are you clear? So for example here, so this is the gas, right? That will be there. This is the gas. In this manner will be there here. So electron configuration, for example, like that will be there. So here, so I have in this manner electron configuration. Okay, electron configuration will be there. So now one electron I can remove this side, extract one electron. So in that case what happens? It becomes a positive, these electron free electrons. So now this gas is ionized gas. Ionized gas. Now this ionized gas can conduct electricity. Alright. So here current carriers. Current carriers are in gases are positive ions and free electrons. So positive ions and electron. Positive ions and electron. Positive ions and electron are the so constitute current in gases. Current in gases. Okay, generally gases is the so bad conductor. Do not conduct any electricity. But so because of ionization, it can constitute electricity. Are you clear? So similarly, one more point also will be that is the semiconductors. In semiconductors, what are the current carriers? In semiconductors, what are the current carriers? Yes, in semiconductor, semiconductors is nothing but at low temperature, these are the act as the insulator. At high temperature, these are the act as a so conductors. At high temperature, semiconductors act as a conductors. At low temperature, these are act as a insulator. That is why we are calling semiconductors. But in semiconductors, current carriers are holes and free electrons. Okay, what is the hole, what is the free electron, this and all we will discuss in the semiconductors. But remember, what is that? In the semiconductors, so current carriers are holes and free electrons. Are you clear? This is the first concept. Right. So now we will solve some problems. Whatever concept till now I have given. So based on that I will solve some problems. Right, now problem number 1. What is the problem is given? The total, so 6.0 into 10 power 16 electrons pass through any cross section of a conducting wire per second. Find the current. Okay, now what is the given question? The total number of electrons is given. Number of electrons is equal to how much? My N is equal to 6 into 10 power 16 electrons. Okay, so time is equal to per second mean 1 second. Okay, so then charge of electron involved, what is that? 1.6 10 power minus 19 coulombs. Right? Then I is equal to what? What is I formula? I is equal to Q by T. Where Q is equal to, formula Q is equal to N into E. Correct only, na? So that is why I have written here Q is equal to N into E divided by T. So N is equal to how much? Substitute values. 6 into 10 power 16 into 1.6 into 10 power minus 19 divided by 1 second. So how much will come? Minus. So 3 will come. Correct only, na? So 16 6 80, right? 96. 16 6 96. Therefore 9.6 into 10 power minus 3 ampere. Correct? So I is equal to 9.6 milliampere. 10 power minus 3 milli, right? 10 power minus 3 means milliampere. Alright. That is the answer. Finish. Very simple question. Next, in a hydrogen, This is the H. In a hydrogen atom, electron moves in an orbit of radius. Electron moves in orbit of radius is, so how much is given? 5 into 10 power 11 meters is given. So these electron velocity is equal to how much? So 2.2 into 10 power 6 meter per second is given. Then what is the equivalent current? What is the equivalent current? This is the based on velocity, right? Based on velocity as well as the time radius formula. Right. So R is equal to how much? 5 into 10 power minus 11 meters. Velocity 2.2 10 power 6 meter per second. Then I is equal to what? What is I formula? I is equal to Q by T. Yes or no? T is equal to time period. So total distance by velocity. Distance is equal to what? 2 pi r. Velocity. So V goes to numerator. Right? I have given already formula. Now substitute all values. So E is equal to 1.6 into 10 power minus 19. Velocity is equal to how much? 2.2 into 10 power 6 divided by, so 2 into 3.14 into radius. How much? 5 into 10 power minus 11. So minus 11, this one get cancelled, minus 8 will come. So get cancelled, minus 2 will come. Yes or no? So 0.8, correct? Then now calculate this one, 0.8 into 2.2 into 10 power minus 2 divided by, so this one, so 3.14 into 5. Do calculation clear, fast. Calculation fast. So answer will come 1.12 into 10 power minus 3 ampere. Minus 3 ampere, or else 1.12 milliamperes. Milliampere. This is the answer. Right? Okay, next. Right. Next problem number 3. What is given? The current through a wire depends on time, as I is equal to I naught plus alpha into T, where I naught is equal to how much? 10 amperes is given. Alpha is equal to 4 ampere per second is given. Find the charge that closed through a section of the wire 10 seconds. Closed, you can remember this one. 0 to 10 seconds. Closed means 0 to 10 seconds. Yes or no? That is the given, 0 to 10 seconds. So what is the charge? Charge is equal to how much? Very simple question, right? So I is equal to, given I is equal to I naught into alpha plus T. I naught plus alpha into T. I naught is equal to 10 ampere is given. Alpha is equal to 4 ampere per second is given. T is equal to 0 to 10 second is given. Then Q is equal to what? You know formula, I is equal to Q by T. I want to Q, right? Therefore, Q is equal to I into dt. This one I have written dq is equal to I into dt. Correct? Generally formula. So I is equal to, what is that? dq by dt. Therefore, dq is equal to I into dt. I into dt. Therefore, dq is equal to, I is how much formula? I naught plus alpha into t into dt. Right? So, dq is equal to q naught, sorry, I naught into dt plus alpha into t into dt. Correct or not? Now both are take integration. Yes or no? Where 0 to 10 seconds. 0 to 10 seconds. So I naught value how much? 10 amperes. Take common. So integrate dt, t1 in a t value how much? 10. Plus alpha value how much? 4 ampere per second. This is the t square by 2, right? T square by dt mean what is that? T square by 2. T value how much? 10. 10 is 100 by 2. So 2 2's. So how much here? 300. 100 plus 200 is equal to 300 coulombs. Negative dq is equal to q. That's it. Finish. Simple question. Right. Next question is, a current is in a discharge tube. Discharge tube. Previous also I have given this one, right? Discharge tube. Like that. This is a positive, this is a negative. So protons, positive ions are moved from positive to negative terminal. Negative ions move from negative terminal to positive terminal. This is the positive terminal, this is the negative terminal, right? Okay, so cross section area is equal to 8 into 10 power minus 4 meter square. When a sufficiently high potential difference, nearly here we are given potential difference is equal to, so here some potential will be given, so 32 volt. Okay, not required, that is. So potential difference is that means here no need to mention, but compulsory voltage is required, otherwise current cannot flow, right? Okay, so potential difference is applied across the two electrodes in the tube, right? The gas uh, what is that, consists. Okay, the gas, what is the question I missed out there? So the gas ionizes, this is one. The gas ionizes electrons and positive ions. The gas ionizes electrons and positive ions are moving in opposite direction. Yes, positives move from positive to negative, electrons can move from negative to positive. Okay, if number of electrons 3 into 10 power 18 and number of protons 2 into 10 power 18 moves in each second, then find the total current. Yes, you know kind of what is I is equal to, so number of electrons, number of number of protons into each electron proton charge by T, Q by T. Correct? How many electrons are there? Ne. How many protons? Np. The total. Alright. So Ne is equal to 3 into 10 power 18 plus 2 into 10 power 18. So into 1.6 into 10 power minus 19 charge of electron. So T is equal to how many seconds? 1 second. Correct? Then 10 power 18 take common, so get cancelled. So minus 1 will come. So 3 plus 2, 5. 5 into 16, 18. 8 into 10 power minus 1. So 0.8 amperes. Right? 3 plus 2, 5. 5 into 16, 1.6, 16. 16 5 is 18. Correct? 8 into 10 power minus 1. So 0.8 amperes. Correct? So that is the answer. So move from positive to negative. Right? Okay, next. Right. So problem number 5. So very interesting problem. Problem number 5. Once we have to see a potential difference of 100 volt is applied to the ends of copper wire 1 meter long. Copper wire length is how much is given? Copper wire length is equal to 1 meter is given. 1 meter. Calculate the average drift velocity of electrons. So they are asking drift velocity. Drift velocity. That is the first question. Second one, compare it with thermal velocity. Thermal velocity. So thermal velocity. What is thermal velocity here? VRMS velocity in the copper wire. So at how much temperature? 27 degrees Celsius. T is equal to how much is given? 27 degrees Celsius. So convert into Kelvin, 300 will come, right? 27 plus 273. We know already. Right. Consider there is one conduction electron per atom. There is one conduction electron per atom. Okay. Then the density of copper wire is how much is given? 9 into 10 power 3 kg per meter cube. And molecular weight. A means molecular weight. Okay. So molecular weight, M I will give you. Molecular weight of copper is equal to 63.5 grams is given. Grams, we know already. Avogadro number is 6.0 into 10. They are given. Okay. So they given like that in the question. 6.0 into 10 power 23. Okay. So then sigma mean conductivity. Conductivity is equal to 5.81 into 10 power 7 ohm inverse. Ohm inverse. And kV means Boltzmann constant. 1.38 10 power minus 23 joule per Kelvin. Joule per Kelvin. Then what is the question asking? So Vd, first question is drift velocity. Second question, comparison. So Vd by Vrms is equal to what? Vd by Vrms. Okay. So here one important formula we want to remember this one. What is that? This formula, you know, in the first year KT, kinetic theory of gases, I have given mu is equal to n by a. Number of molecules by what is that? Avogadro number. Number of molecules by Avogadro number. Correct? N by Na. Equation number 1. Similarly, mu is equal to mass by molecular weight. These two equation. So mu is equal to n by Na and mu is equal to m by capital M. So from 1 and 2 what we can write here? So n by Na is equal to m by m. Correct? Therefore, I want to n, number of molecules. Okay, number of molecules I want. Number of electrons, that means. So n is equal to m by capital M into Na. Number of molecules is equal to m by m into Na. This formula I want. Okay, so this formula I got. Finish. So next. So this formula you can observe there. Again here mass is not given. That mass we can convert into density term only. Therefore, n is equal to rho by V, density by volume. This is the density. Rho mean here density, not a resistivity, into Avogadro number by molecular weight. Then V you can transfer that side. So n into V is equal to rho Na by molecular weight. Okay, now you know already n into V is equal to, what is that? Small n only, na? Yes or no? Small n, sorry. So what is the formula? Small n is equal to number of electrons per unit volume only, right? So I done mistake, right? Okay, 1 second more. Right, extremely sorry here, ma. This is I done mistake here. What is that? Mass density is equal to mass by volume. So mass is equal to what? Density into volume only, right? Density into volume, not a density by volume here. So rho into V. This V you can transfer that side. Then it is becomes n by V. N by V. N by V is equal to small n, right? Okay, now correct. So n is equal to rho into Na by m. So n is equal rho is equal to how much? Rho is density. Density is equal to 9 into 10 power 3 into Na. Avogadro number 6 into 10 power 23 divided by. So molecular weight how much? 63.5 grams is given, right? 63.5 into 10 power minus 3 kgs. If you do calculate, you will get answer 8.5 into 10 power 28 per meter cube will come. Okay. Then drift velocity. What is the drift velocity formula? So sigma E divided by n into E. Correct? This formula also we know already. Vd is equal to sigma E divided by n into E. How you got this formula? You know already. What is that? J is equal to NE Vd. J is equal to what formula? Sigma into E, right? Sigma into E. Therefore, I want to Vd. Vd is equal to sigma E by Ne. So that is I written here. And E is given in the question? No. They given potential difference. So that E you can write in potential terms only. So you know formula, one more formula. What is that? E is equal to V by L, right? E is equal to V by L. Therefore, E is equal to V by L. So now all values substitute there. Sigma is equal to 5.81 into 10 power 7. V is equal to 100. N is equal to 8.5 into 10 power 28. E is equal to 1.6 10 power minus 19. L is equal to how many meters? 1 meter is given. Therefore, 1 meter I have written here. If you do calculation, you will get answer 0.43 meter per second will come. You can do yourself calculation. Okay, right. So now Vd I got. Vd is equal to 0.43 meter per second. Then next I want to Vrms. I want to VRMS. I enter into this side here. You can observe. VRMS formula you know. Correct? VRMS formula is equal to root over 3 kBt by mass of electron. Mass of electron. This formula also I have given in the kinetic theory of gases. Okay. So VRMS is equal to 3 kBt divided by mass of electron. Correct? Kinetic energy is equal to kinetic energy in kinetic theory of gases. 1 by 2 m VRMS square is equal to 3 by 2 kb into T. So 1 by 2 get cancelled. VRMS is equal to 3 kBt by mass of electron will come. We are speaking mass of electron on, right? Okay. So 3 only. Kb is equal to 1.38 into 10 power 23. T is equal to 300 Kelvin. So mass of electron 9.1 10 power minus 31 kgs. If you do calculation, you get answer. Thermal velocity is equal to 1.17 in 10 power 5 meter per second. Correct? That's what I told previous also. Thermal velocity is the maximum. That is a very high speed. How much? 1.17 into 10 power 5 meter per second. Oh, right? Okay. Now comparison. Vd by VRMS. Vd is equal to 0.43 10 power 0.43. VRMS is equal to 1.17 10 power 5 goes to numerator and becomes 10 power minus 5. Right? If you do calculation this one, you will get answer 3.67 into 10 power minus 6 meter per second. That is the Vd by VRMS. Vd by VRMS. Are you clear? Okay. Next, sixth problem. Sixth problem I have given. Consider a wire of length is 4 meters and cross section is 1 millimeter square. 1 millimeter square. Carrying current of 2 amperes. Carrying current is 2 amperes. And if each cubic meter, each centimeter cube, each cubic meter of material contains how many electrons? 10 power 29 free electrons. Okay, number density, number of electrons per unit volume is equal to how much? Cubic meter. Okay, meter cube, not a centimeter cube. So cubic meter cube. Correct? So small n is equal to 10 power 29 per meter cube is given. Free electrons. Find the average time by an electron to cross the length of the wire. They are asking time only. Time is equal to what? Very simple problem. This is the NCERT, I think 3.15 problem. 3.15. Okay. Once you had to observe this problem in the textbook also. So I is equal to formula, you know, relation between I and Vd. I and Vd relation. I is equal to NaeVd. Here Vd drift velocity I've written distance by time, length by time. I want to T. So T you can transfer that side, you can take this side. Therefore T is equal to Nael by I. Okay. So n value is equal to how much? 10 power 29. A value how much is given? 1 millimeter square. Convert into meter square. Okay, meter square. What is that? Area of cross section 1 millimeter square. How much will come? So 10 power minus 4, right? Yes or no? 10 power minus 4 meter square will come. Right? Then next. So E is equal to 1.6 10 power minus 19 coulombs. L is equal to how many meters? 4 meters. And I is equal to 2 amperes. Now do calculation. So if you do calculation, you will get answer. So T is equal to 3.2 into 10 power 4 seconds will come. 3.2 into 10 power 4 seconds will come. Are you clear? So that is the answer. T is equal to 3.2 into 10 power. So 10 power 4 seconds will come. Right? Okay. Next. Right. So next Ohm's law. So now the most very important law. This is the Ohm's law, right? Ohm's law. So one of the most important question, ma'am. So 1 mark or 2 mark question definition. So this is a given by G.S. Ohm, George Simon Ohm. His name is what? George Simon Ohm. Is a given relation between potential and current. Relation between V and I is given relation between V and I. That means the flow of current through a conductor is directly proportional to the applied potential difference at a given temperature and pressure, right? Okay, so what is the given statement here? So for a given conductor at a given temperature, for a given conductor at a given temperature, the strength of electric current, through it is directly proportional to the potential difference applied across it. So this is the Ohm's law. What is that? For a given conductor at a given temperature, the strength of electric current through it is directly proportional to the potential difference applied across it. What is that meaning? I is proportional to V, or V is proportional to I. Any formula, no problem. Alright, so V is proportional to I is nothing but V is equal to proportional constant. We will consider R only. Right? Your proportional constant is R. R is nothing but resistance of a given material. Resistance of a given material. What is the meaning of a resistance of a given material? Whatever it is that. Alright. Okay, so V is equal to IR formula. Remember, very important formula. V is equal to RIR, IR. V is equal to here. In this formula, what is that? I is equal to is equal to V by R will come. So I and R both are inversely proportional. Therefore, V is constant, right? V is equal to I into R. V is constant. If I is increasing, R can decrease. R can increase mean I can decrease. Therefore, V is constant. V is equal to IR. V is equal to IR is the Ohm's law. Alright. So, V is equal to IR. That's it. So, next one more small question they will ask question. What is that? Deduce Ohm's law. Deduce Ohm's law. Alright. For 3-mark purpose, they will ask sometimes. Okay. You have to remember deduce Ohm's law. That means we want to derive the Ohm's law with the help of drift velocity. With the help of drift velocity as well as current only. Right. Okay. So, this is the question. Deduce Ohm's law. Deduce Ohm's law. Therefore, answer is from relation between drift velocity and current. Drift velocity and current. What is relation? I is equal to NAEVD. NAEVD. That is the drift velocity. Correct? Sorry, drift velocity and current. So, I is equal to NAE. Drift velocity formula, what is that? E by M into tau, right? Okay, magnitude only. E by M into tau. So, E into E is square. Okay, NA by M, and E general formula, what is that? V by L. V by L. So, I will written instead of V, E, V by L. Okay, na? Right. So, now I want to V. So, V is equal to I have written here only, M into L, transfer that side, M into L divided by this and all will becomes denominator, right? Therefore, N A E square into tau. So, V is equal to I into this total we will consider as a R. Therefore, V is equal to R into I. Where R is equal to what? R is equal to M L divided by N A E square into tau. This is the our Ohm's law derivation. Finish. V is equal to IRR. V is equal to R into I. Where R is equal to this one. Correct? Similarly, one more relation you know already. What is that? Resistivity, specific resistance. Specific resistance. What is that? Rho is equal to R into A by L. We learn already class 10th also. Later I will give you. But just you have to remember. What is that? Rho is equal to R into A by L. Correct? Resistivity formula, specific resistance. Specific resistance formula, rho is equal to R into A by L. Where R is equal to what? ML into A divided by N A E square into tau. A get cancelled, LL get cancelled. Therefore, rho is equal to M divided by N E square into tau. What is that? Rho is equal to M by N E square into tau. Correct? Then now you know formula already. So here rho is equal to, I can write it 1 by rho. 1 by rho. 1 by rho means sigma 1 in it. 1 by rho means sigma. So sigma is equal to 1 by rho. Reverse. If I write reverse, 1 by rho is equal to what will come? N E square by M into tau. What is the meaning of 1 by rho? Conductivity. 1 by rho means conductivity. So sigma is equal to N E square by M into tau. This one also derivation I have given already previous. First essay question, right? Sigma is equal to N E square by M into tau. So with help of Ohm's law, I have given this one. Right? Okay. So that is the finished one. So next very important 3 mark question, that is the give the relation between J and sigma. Give the relation between J and sigma, and also this one we can call it one more name also, derive expression for vector form of Ohm's law. Vector form of Ohm's law. This is the J bar is equal to sigma into E bar is the vector form of Ohm's law. Right? Very important 3 mark question by this one. So give the relation, we arrive at J bar is equal to sigma into E bar, or else give the relation between J bar and sigma. J bar and sigma and E bar, and also you can write it this terms also. J is equal to current density, sigma is equal to conductivity, E is equal to electric field. Right? Now we will consider as a one conductor. So this is a conductor. So its length is equal to L. Okay, I have given electric field. Potential I applied there. Okay, now I supplied electric potential through this end. A and B. For example, this is the A, this is the B, and potential difference is equal to V, and electric field is equal to V. And drift velocity is moving from here to here. This is a drift velocity. Everything we know. Correct? So consider a conductor of length is L, area of cross section is A, connected a battery as shown in the figure. Right? So let V is the potential difference between ends of the conductor, potential difference, and Vd is the drift velocity. Right? So now the uniform electric field in the conductor, E is equal to, so many times I have given this formula, right? So E is equal to V by L. So third point, that is I have given the uniform electric field in the conductor is E is equal to V by L. Therefore V is equal to E into L. That is the equation number 1. Right? V is equal to E into L, equation number 1. Then next, from Ohm's law, we know V is equal to I into R. From Ohm's law, V is equal to I into R. So this is equation number 2. So from 1 and 2, this one also potential, this one also potential difference. Both are potential difference only. Both are LHS are equal, right? I can equate RHS only. Therefore, EL is equal to I into R. But R formula you know. So R is equal to general formula. Remember, R is proportional to L. R is proportional to 1 by A. So from 1 and 2, R is equal to rho into L by A. This is a class 10th. We learned already. Correct? Next I will that one also. What is that? R is equal to rho into L by A. Instead of R, I have written rho into L by A. So L get cancelled. This rho you can transfer to that side. So E by rho is equal to I by A. What is the meaning of I by A? Current density J. Correct? So E 1 by sigma. 1 by sigma is equal to 1 by sigma is equal 1 by rho is equal to sigma, right? 1 by rho is equal to sigma. Therefore 1 by rho is becomes sigma into E. Therefore J bar is equal to sigma into E bar. Sigma into E bar, right? Okay, next. Right. So next one more small question, one more question only. This is, what are ohmic and non-ohmic devices? What are the ohmic and non-ohmic devices? Yes, you know, ohmic devices mean which are obeys Ohm's law. Which are obeys Ohm's law. That is called ohmic devices or ohmic conductors or linear conductors. Okay. So similarly, non-ohmic, which are do not obey Ohm's law, which are do not obey Ohm's law. These are nothing but non-ohmic conductors or non-ohmic devices. Okay, so that is I given there. We had one subject. What is that? Ohmic devices. Ohmic devices mean the devices are substances which obey Ohm's law are called ohmic conductors or ohmic devices. Ohmic conductors or ohmic devices. Okay, na? So examples are galvanometer, ammeter, etc. Okay, galvanometer and ammeter, etc. These are the ohmic devices. Similarly, non-ohmic or non-linear devices. The devices are substances which do not obey Ohm's law. Which do not obey Ohm's law are called non-ohmic or non-linear devices. Non-linear devices. Okay, na? Examples are transistors, semiconductors, diodes, etc. These and all. Okay, thermistors and all. These and all non-ohmic conductors. Okay, na? Very, very important. One mark question. This is very small question. Next, one more 3 mark question or 2 mark question. What is that? What are the limitations of Ohm's law? Limitations of Ohm's law. Alright? So any 3 points you can write in examination. So first point is, Ohm's law is not applicable at a very low and very high temperature. Correct, right? So Ohm's law do not applicable at low temperature as well as at a high temperature. It is not suitable. That's why this is not a universal law. Okay. So what is that? It is not applicable at a very high and very low temperature. So normal temperature only it is applicable. Okay. So second point, Ohm's law is not holds good. Not holds good for non-ohmic devices. Non-ohmic devices such as semiconductors. Such as a semiconductor do not hold good, such as a semiconductors, and for which the VI graph, V versus I graph, is gives non-linear, not a straight line. So curved line will come like that. This is a graph of VI for non-linear conductors. Okay. So, but and also you can remember here, V is equal to IR is applicable for non-linear as well as linear. What is that? V is equal to IR. But V is proportional to I is not applicable for non-linear. It is only applicable for only linear. It is applicable for only linear. But do not applicable for non-linear. Alright? Okay. So that is here written. What is the V is proportional to I is not applicable for non-linear. It is applicable for only linear, right? Okay, next third point. Ohm's law valid only for linear conductors. Ohm's law valid for only linear conductors. Only linear conductors. For linear conductors, V versus I graphs or straight line will come. Or straight line. Okay. So if I draw graph V versus I like that, V along y axis, I along x axis. I along x axis, straight line will come. For this purpose, if I draw slope, m is equal to tan theta is equal to v by I only, na? V by I is equal to what? R only. That means resistance R is equal to V by I will come. V by I, that is the resistance. If I draw graph I versus V like that one, I along y axis, V along x axis. Okay, here theta will come. Then slope is equal to tan theta is equal to I by V. I by V mean 1 by R. 1 by R means G. What is the meaning of G? Conductance. Okay, not a conductivity. Conductance. What is the meaning of conductance? Conductance is nothing but the reciprocal of resistance. The reciprocal of resistance is known as conductance. Conductivity means the reciprocal of resistivity. The reciprocal of resistivity is known as conductivity. Alright? So, and one more point. This third point, next to fourth point I had given here. See once. What is that? Ohm's law is not applicable for semiconductors, vacuum tubes and discharge tubes, thermistors, etc. These are the limitations of Ohm's law. Very, very important question for this one. Limitations of Ohm's law. Are you clear? You have to read clearly this one. You have to remember limitation. It is applicable for only good conductors. Okay, it is not applicable for non-linear conductors. That means non-ohmic conductors. Right? So it is applicable only at very low, not applicable for very low and very high temperature, not applicable. Right? Okay. Right, in this session I can stop here only. So next topic is the resistance. That is a big topic, so it will take again 40 to 50 minutes only. That is why I can stop this session here only. So in this session I have given completely only just Ohm's law. What is the Ohm's law? Okay, what is deduce? What is the formula of relation between J and sigma? Deduce Ohm's law. These are the very, very important questions, as well as Ohm's law limitations, as well as ohmic and non-ohmic conductors I have given. Similarly, some problems also starting I have given, right, based on current formulas. Based on current. Correct? I is equal to Q by T, I is equal to V by 2 pi R. This and all I have given, right? So these problems you have to practice, as well as inside next two problems also you have to do based on this concept, right? Okay, so thank you to one and all. Thank you.